Welcome to this video. We're going to finish off the 1993 AP Calc AB multiple choice product exam, and we left off on number 36. So let's begin. If the definite integral from 0 to 2 e to the x squared dx is first approximated by using two inscribed rectangles of equal width, and then approximated by using the trapezoid rule with n is equal to 2, difference between the two approximations is, you will need a calculator for this problem, but to set it up, where did I do it? Okay, so why did it write inscribed? That means it's going to be an underestimate of what the integral actually is. So the rectangles are inside the function, okay? So how does e to the x squared look? It looks very close to e to the x if we just sketch it. E to the x looks something like this, okay? Now, we want the integral from 0 to 2 inscribed rectangles or two trapezoids. So delta x is 2 minus 0 over 2, which is equal to 1, okay? So the width of each rectangle is 1, or the height of each trapezoid is 1, okay? So with the inscribed rectangle method, because our function looks like this, we want it to be inside, inscribed. So we want to use something like this, right? We want to use left endpoints over here, okay? So let me even draw the interval out. It's from 0 to 2, delta x is 1. So here are our two intervals, 0 to 1, 1 to 2. So we're going to use the left endpoints. Okay, so we want f of 0 plus f of 1. To recap, we want the area of each rectangle. So it would only be 2 of them, not 3 of them like I drew here. But anyway, I was saying that area of the rectangle is the base times the height. The base is just 1. The height is the value of the function, so f of 0. So 1 times f of 0 plus 1 times f of 1. So that's equal to, what is f? That's just e to the x squared. So e to the 0, which is this guy, e to the first power, which is this guy over here. So we're left with 1 plus e. That's the area with two inscribed rectangles. So we do next the trapezoid rule. Okay, so we have the same intervals, but we're going to have trapezoids instead. So what's the area of the trapezoid? Average of the bases times the height. The bases are, so in this interval, it'll be f of 0 and f of 1. So it's f of 0 plus f of 1 over 2, that's the average, times the height is again 1. So f of 0 plus f of 1 over 2, plus f of 1 plus f of 2 over 2 for the other trapezoid, okay? So if we plug it in, or exact form, it'll be 1 plus e over 2, e plus 4 over 2, okay? So we just take the difference between this guy and this guy. And in the calculator, you should get what? I did not write it down, so let me look at what the key is. Okay, so I did get this and this, so we just subtract them. The key says it's 26.79, something like that. So this guy, okay? I didn't plug it into the calculator, but that should be the answer. Okay, if f is a differentiable function, the f prime is given by which of the following. This is just the difference quotient, limit definition of the derivative. So limit as h goes to 0, f of a plus h minus f of a divided by h. This is probably the more common definition. That's good. Limit as x goes to a, f of x minus f of a divided by x minus a. This is also good. This is also a definition of the derivative, okay? Because as x approaches a, it's going to approach this point, and the y would approach f of a, and the x would approach a, okay? So it's the same thing. Now how about this one? Limit as x goes to a, f of x plus h minus f of x over h. This doesn't even depend on a, so this is not it, okay? So it's 1 and 2 only. Okay? 38. Second derivative of f is given by this guy, which could be f. So we want to find the antiderivative twice, or integrate twice. So f prime would be x squared over 2, so the 2 here and the divide by 2 would cancel. Integral of cosine is sine, so minus sine x plus c. Okay? Now we want to find f So we need to integrate once more. So f, not f prime, let me erase that. F would be, again, parable. X cubed over 3. Antiderivative of sine is negative cosine. So it becomes plus cosine x plus c times x plus some other constant. Let's call it d or something like that, okay? So which one is the answer? So it has to be x cubed over 3 plus cosine x. So that's only this one. 38 is A. Okay? Radius of a circle is increasing at a non-zero rate. And at a certain instant, the rate of increase in the area of the circle is numerically equal to the rate of increase in its circumference. At this instant, the radius of the circle is... Okay, so this is a related rates problem. What did it tell us? Radius of a circle is increasing at a non-zero rate. Rate of increase in the area of the circle, so that's dA dt, okay, is equal to the rate of increase in the circumference. So that's dc dt. That's what I wrote over here. dA dt is dc dt. Okay? We want to know what the radius is at that point. Okay? So if I write the formula for the area of a circle, A is pi r squared, and the circumference of a circle, that's 2 pi r, differentiate both of them. dA dt would be 2 pi r dr dt. dc dt would be 2 pi dr dt. Okay? Derivative of r is just 1, but we implicitly differentiate. Okay? We set these two equal to each other, because that's what we wrote over here. Okay? So 2 pi r dr dt is 2 pi dr dt. The 2 pi's can cancel. So we're left with, and the dr dt's can cancel, by the way. So we're left with r is equal to 1, because we're only left with 1 on that side. Okay? So r is 1. Okay, let's move on. 5 more problems. As soon as I can flip the page. This guy says the graph of f is shown in the figure above. Which of the following could be a graph of y is f of absolute value x? Okay, so what's the absolute value being applied to? It's being applied to the domain. So let's take an example. When x is -1, then it's f of absolute value of -1, which is f of 1. Okay? So this is basically just saying it's an even function. Okay? So it needs to be symmetric about the y-axis, first of all. That's what an even function is. Right? Because remember what even function is? F of -x is f of x. This is what's happening here. When we plug in -x, the absolute value get rid of the sign, so it becomes just x. Okay? So it's an even function. So let me write that over here. Those are key points. So let's find out which ones are not even and cross them out. This is not even, this is not even, this is not even. Remember, once again, even function is symmetric about the y-axis. Okay? So now, which one of these two is the answer? Okay, well, if you take a look here, the positive x should be unaffected. Because when x is positive, absolute value of x is also x. Okay, so the positive x should be unaffected. So this one's unaffected, this is affected. This reflected up here. So this is actually the absolute value of f of x in this section over here. Okay, this is the absolute value of the y, not of the x over here. So we cross that out. The answer is C. Okay. Oh, this is easy. Derivative of integral from 0 to x cosine 2 pi u du. Fundamental theorem of calculus. What do? We just plug in the limit as the variable of integration. So cosine of 2 pi x times derivative of x, which is just 1. 41's D. As simple as that. Easy points. Puppy weighs 2 pounds at birth and 3.5 pounds 2 months later. If the weight of the puppy during the first 6 months is increasing at a rate proportional to its weight, this is key, this should signal exponential growth, then how much will the puppy weigh when it's 3 months old. Okay, so if this key point didn't ring a bell, this should signal to you exponential growth. Okay, if not, we can quickly derive it again. Okay, so if the weight is W, the weight is increasing at a rate proportional to its weight. Okay, so that's the rate of change is proportional to the weight. That's what this is saying over here. Okay, so we integrate both sides by separation of variables. Remember that method? Then this would be like WT is some initial value. I call it W0, e to the kt. Or remember, if you remember exponential growth indicates CE to the kt. If that sounds familiar, same thing. I just wrote it as W0 for initial weight. Okay, so it tells us the initial weight is 2 pounds. So I can plug that in as W0, 2e to the kt. They say that it's 2 pounds at birth and 3.5 pounds 2 months later. So when t is 2, W of 2 is equal to 3.5, which is equal to, we plug in t as 2 there. So it'll be 2e to 2k. We solve for k. How to do that? Well, we divide by 2 on both sides first. That's over here. We get to this line, we log both sides, so that's over here, and then we divide by 2 to get the growth constant, okay? So we found what k is. They're now asking how much will the puppy weigh when it's 3 months old, so they're asking what W of 3 is. So we just plug in again into our W equation. So that's here, and then we even found k. So 2e to the k, which is down here, times 3, t is 3, okay? So this we plug into the calculator, you should get 4.63 pounds or something like that, right? So it should be B. Okay? This guy, integral of x f of x dx, this looks like integration by parts right away because we have a product of two things and then looks like we have a uv minus integral v du. Okay, so which one's u, which one's dv? Okay, well, it looks like all the first terms, besides this one, there's only one term, are f. So we probably want this one to be u to be f. Okay, so du would be f prime of x dx. dv would be what's left, x dx. v is equal to x squared over 2. Okay, so it's uv minus integral v du, so x squared over 2 f of x. That looks like this one up here, minus integral v du, so integral x squared over 2 times f prime. So that's 43 is b. Okay. Next, 44. What is the minimum value of f of x is x ln x. Minimum value, let's take the derivative. Okay, so I'm going to do it up here. F prime would be, we need to product. Well, first d second plus second d first. So first, d second derivative of 1 ln x is 1 over x plus second derivative of x is just 1. Okay, we set this equal to 0. Okay, so how do we solve this equation? Well, this would reduce to a 1. 1 plus ln x is equal to 0. Okay, ln x is -1, or x is equal to e to -1. Okay, so let's do our first derivative test. We only have one critical point, which is that e is -1. Okay, we plug in some number much less than e to -1, like, well, the log isn't defined for negative numbers, so let's plug in like what? Something very close to 0. Okay, we know the log will go to -infinity as it approaches 0. So -infinity plus 1, that's a negative. Okay, and we plug in a huge positive number. We know as x gets bigger, ln gets bigger, so it'll be positive. Positive plus 1 is positive, right? So we confirm that there's a min at e is -1. Okay, so what is the value? That's what it's asking, value. It's not asking where it is. Okay, and in fact, there's no choice of e to the negative 1. So don't get tricked by, oh, maybe this is e to the negative 1, but I forgot a minus sign somewhere. Okay, no, we have to plug it back into here. So f of e to the negative 1 is e to the negative 1 ln e to the negative 1, which is minus e to the negative 1. Oh, okay. In fact, it was c. Okay, coincidentally, but... Or maybe you picked that, I don't know. But this is the correct answer, okay? Minus 1 over e. And then the last problem, oh, is Newton's method, okay. This might take a while if you're not familiar with it. If Newton's method is used to approximate the real root of x cubed plus x minus 1 is equal to 0, then a first approximation x1 is equal to 1 would lead to a third approximation of x is equal to what? Okay, so if you just remember the formula blindly, that's okay. Where did I do it? Okay, but remember what Newton's method is. This is what the graphing calculator does exactly. We have an initial guess, and then it starts taking derivatives. So let me even... Let's take this 0 as an example. We have initial guess, like right over here. Okay? This is our initial guess, x1 at x1. Okay? We find the equation of the tangent line. Whoops. Okay? So it crosses the x-axis here. So this is our x2. We find the equation of the tangent line at that point. Okay? So it'll be something like this. Okay? So it gets closer. Here would be our x3, and then we continue, and then it will get closer and closer to the actual 0, okay? So how do we find that? Well, how you remember it is x of n plus 1, the next sample point, not sample point, that the next x value is x, the previous, or the current x value, minus f of x sub n over f prime of x sub n. So this is all about the current value to find the next value. And this is literally just tangent line, okay? So, what did I do here? Okay, so we know that x of 1 is 1, so let's find x of 2. That's just x sub 1 minus f of x sub 1 over f prime of x sub 1, okay? So what's x sub 1? That's 1. What's f of x sub 1? So what's f of 1? We plug in there 1 plus 1 minus 1. That's 1 again, okay? How about what's f prime of 1? Well, f prime, let's find the derivative. Derivative of this guy is just 3x squared plus 1. So when we plug in 1 as x, we get 4. So our x2 would be 3/4. Okay? So then we use this guy to get our next point. 3/4 plus f of 3/4 over f prime of 3/4. Okay? And this, I would just plug it into the calculator, and you should get this guy. Okay? That's the idea of Newton's method. You use the tangent line to find the next point that's closer to that 0. This doesn't always work, as if you see in your calculator, you have to enter 2 points even. So that's how it helps it find that 0. But it doesn't always work because, for example, if you guess it exactly at this minimum, then you'll never get to that 0, okay? So you have to pick a point that's close to the 0 as the initial guess, okay? So hopefully this was helpful. Please like the video if it was, and please subscribe to the channel to look out for the next year. The next year's multiple choice problems.